How does a car see the world? How does Netflix know which movie you'll want to watch on a Friday night before you do? How does Spotify listen to 3 of your favorite songs and magically build the perfect playlist? Behind these modern miracles, behind the artificial intelligence that is reshaping our world, there is a secret language. A language designed not for computers to understand, for people to understand. It was created by one man who was tired of the old way of doing things, who believed that programming should be as simple as writing down an idea. This isn't just a programming language. It's a philosophy, and it's the key that will unlock your journey into the world of AI and machine learning. This is the story of Python. To really understand Python, we need to go back to the late 1980s. Imagine the world of programming back then. Programming languages were like ancient texts filled with cryptic symbols, rigid rules, and baffling syntax. You had to wrestle with the computer, forcing it to understand you through a maze of brackets, semicolons, and declarations. It was powerful, yes, but it was also slow, frustrating, and incredibly difficult for beginners to learn. A Dutch programmer named Guido van Rossum was working on a project and got fed up with this complexity. He believed there had to be a better way. He envisioned a language that was powerful, but also clean, readable, and intuitive. A language that lets you focus on solving the problem, not fighting with the syntax. So, during a Christmas holiday break, he started a side project. He named it Python, not after the snake, but after one of his favorite comedy troupes, Monty Python's Flying Circus. That sense of fun and accessibility is baked into Python's DNA. So, what is Python officially? The textbook definition says it's an object-oriented, high-level, interpreted programming language with dynamic semantics. Okay, let's be real. That definition is completely useless to a beginner. Let's translate that into English. High level simply means it's a language that's closer to human language. You write in words that look a lot like English, and Python handles the complicated business of translating that into the ones and zeros the computer actually understands. Object-oriented is a fancy way of saying it lets you build your programs using digital Legos. You can create self-contained objects that hold their own data and have their own functions. A user object could hold a username and password. A car object could have functions like drive and brake. It's an incredibly organized way to build complex software. And interpreted with dynamic semantics means Python is flexible and forgiving. Unlike other languages where you have to declare every little thing up front, Python figures a lot of it out on the fly as the program is running. This makes the whole process of writing and testing your code incredibly fast. You write a little, you test it. You write a little more, you test it again. This fast, interactive cycle is what makes developers fall in love with Python. It feels less like construction and more like a conversation. So, why did this humble side project conquer the worlds of web development, data science, and most importantly for us, artificial intelligence? It comes down to a few key superpowers. First, and most importantly, it is ridiculously simple to read and write. Look at this. This is a simple program to print hello world to the screen. On the left is Java. You've got public classes, static voids, string arguments. It's a whole ceremony just to say hello. On the right is Python. It's one line. It's a single readable command. This isn't just about saving keystrokes. This simplicity means you can learn faster, build faster, and your code is easier for other people to understand, which is critical when you're working on a team. Instead of complex brackets to separate blocks of code, Python uses simple indentation. It forces you to write clean code. Imagine you needed to solve a complex math problem. You could spend months inventing a new type of calculus from scratch, or you could just walk into a library and grab a book where a genius has already solved it for you. That's what Python's libraries are. They are massive collections of pre-written code that can do almost anything you can imagine. Want to scrape data from a website? There's a library for that called Beautiful Soup. Want to build a website? There's a framework for that called Django. And for our purposes, if you want to build an artificial intelligence or a machine learning model, there are legendary libraries like TensorFlow, PyTorch, and scikit-learn that contain all the powerful tools built by the smartest people at Google, Facebook, and the entire data science community. Python's power isn't just in the language itself. It's in the vast ecosystem that has been built around it. Python plays incredibly well with others. Sometimes you need the raw speed of a language like C++ for a really intensive task. Python can act as a wrapper or a glue, allowing you to use components from other languages within your Python program. It lets you take the best parts of different technologies and stick them all together. This is why it's so popular for automating tasks and building complex systems. Before we move on, I want to ask you something. For those of you who have tried to learn coding before, what was the one thing that seemed the most intimidating or confusing? Was it the syntax? The logic? Let me know in the comments below. I'd love to hear about your experience. Now, it's not all sunshine and roses. Like any technology, Python has weaknesses, and it's important to understand them. The most common criticism you will hear is speed. Because Python is an interpreted language, meaning it translates your code on the fly, line by line, it is inherently slower than compiled languages like C++ or Java. A compiled language is like having a book fully translated from English to Japanese before you give it to a reader. An interpreted language is like having a live translator sitting next to the reader, translating one sentence at a time. The live translation is more flexible. It's going to be slower. Now, for many applications, this difference in speed is completely irrelevant. We're talking about milliseconds. But for high-frequency trading or the core engine of a fast-paced video game, that speed matters, and Python usually isn't the first choice for the absolute core of those systems. However, and this is a huge however for us when it comes to AI and data science, the real bottleneck isn't the code execution speed, it's the time it takes to process massive amounts of data. And remember those libraries we talked about? The super fast parts of libraries like TensorFlow are actually written in C and just controlled by Python, giving you the best of both worlds, easy to write code with super fast performance where it counts. Another disadvantage is that Python is not native to mobile development. While you can find ways to run Python on mobile devices, it's not the primary language used to build the slick native apps you use on your iPhone or Android device. That world is dominated by languages like Swift and Kotlin. Python's kingdom is on the server in the cloud and powering the brains behind the data analysis and AI that those apps connect to. Finally, some advanced programmers point to its design limitations. Specifically something called the Global Interpreter Lock, or GIL. In simple terms, this can make it difficult for Python to take full advantage of multi-core processors for certain types of tasks. Again, for our purposes in AI and machine learning, this is largely a solved problem, as data processing tasks are often split up in ways that get around this limitation. So, what have we learned? Python is not the fastest language, and it's not for building mobile apps. But those aren't its goals. Python's goal is to be the fastest language from an idea in your head to a working program on your screen. It's a language built for clarity, for productivity, and for powerful, rapid development. It is the undisputed king of data science, automation, and artificial intelligence for a reason. It gets out of your way and lets you build. You now know the origin story of Python. You know its strengths, its weaknesses, and why it was chosen to be the language of the future. You know the why. But knowledge is useless without action. It's time to stop talking about Python and start writing it. Now that you know what Python is, it's time to build your workshop. In the next video, we are going to walk through the essential first steps for any programmer: installing Python on your machine, setting up a professional code editor, and writing our very first lines of real, working code. It's time to go from student to creator. To watch the next part of this course and learn the secrets of getting your developer environment set up in under 10 minutes, click the video on your screen right now.